Okay, welcome to a maths evening, parents workshop. I'm filming this, hi. So hopefully I can put this onto YouTube. So when you go on the school website, you can click on a link because you'll see that the rate of progress the children make at this school from year R through to year 4 in terms of mathematics is quite significant. And for us to try and push that all into 1 hour for you, you might leave with a headache. I sat at the back of the presentation we did on Tuesday, and I had a headache at the end, just thinking it is just amazing. So there's a reference for you on YouTube, as long as it all works, and I can slice and dice all the film. So welcome. When I was first teaching, I had a conversation with another teacher, and she said that reading was more important than maths. Why is that? She said, well, reading can save your life, because you could read a sign which says deep water. And I can argue with that. But I found a clip on YouTube which actually shows you that actually maths can save your life if you get your calculations right. So I wish I'd had that to show my other teacher, to say actually maths is fairly important as well. But I think actually in hindsight she is right. So maths is important, but I'll come back to this at the end of the presentation, reading is actually more important. Sorry for any accountants out there. But maths actually, in terms of what we're going to cover tonight, it can be quite an abstract subject for children. And to just explain that, if we were teaching a child to read and write, they might say a cat sat. And we might teach them that's the A, that's the cat, and that's the sat. And if you put it together, a cat sat, it stays the same. Even these little constituent parts stay the same. So that is still sat, that's the cat, and that's the a. If we do some maths, we say that's a 3, that's a 2, but actually when we add all that together, it all changes, and that's now called a 5. And I know that's a bit I've explained that not very well, but basically there, this stays the same, this changes. So if I've got a 3 and a 2, and I put them together, I get something else. If I put cat and sat together, I get cat and sat. So how does that work? And actually it's quite an abstract subject in some ways. So in lower schools, we have to try and keep maths real. When I've been teaching sort of children maths, if we had 2 numbers, give me a number, somebody call out. 7, fantastic. And another number? 9, okay. Especially in lower schools and going up into up to year 6 and probably most in middle school. When I've been teaching the children, I would say there's only 4 things I can do with those numbers. And that is I can add them, I can minus them, I can take them away from one another, I can multiply them, and I can divide them. And that's it. So whilst maths is this mysterious animal, in terms of number working calculation, there's really only 4 main operations. And that's really what we're going to look at tonight. Tonight we won't look at data collection, or data handling, drawing graphs. We won't look at shape and space and look at coordinates and things like that. It is really this bit, and this is the bit which the children find more tricky sometimes. So we've got Mrs. Green, we've got Mrs. Burnett, so thank you ladies for putting this presentation together. They will start with early counting, and then we'll go on to the addition, subtraction, the multiplication and the division. So sit back, relax. There isn't going to be any questions for you, so it's not going to be so interactive that you have to sit there and worry about, well, someone's going to ask me a question, 7 times 7, quick. It's nothing like that. It's just going to be that you sit back and we're going to take you through each of those, but in the way that we teach it at school, and you'll see the progression. And then I'll speak to you at the end. Okay. Mrs. Green's first, I think.
Thank you very much. Well, having said yes, we're going to be talking about the 4 number operations. I'm actually going to start with early counting. Because in foundation, it's really important that the children are experiencing lots of numbers everywhere. They'll be experimenting with them, they'll be looking for them, they'll be looking outside, they'll be looking inside, they'll be moving things around, they'll be counting them as they're moving. And it's really important that the children do that. And one of the reasons that that is so important is because of something that we call one-to-one correspondence. Because what the children will often do when they first start counting things, they'll be able to sort of rote count, and they'll say 1, 2, 3 in their heads, or perhaps with rhymes and things. They'll manage that fine, but when they actually start to count objects, they'll start saying 1, 2, or they might say 1, 2, 3, 4, and there's only 3 there. So it's really important that one of the things that in the foundation area that they will do is one-to-one correspondence. That's 1, that's 2, that's 3. So they understand that's how it works. Because if they don't get that one-to-one correspondence, when they do come to doing addition, subtraction and all the rest, then obviously the numbers just aren't going to work correctly. So lots and lots of experimenting, investigating and things like that in foundation to get a solid understanding of what number means first of all.
Okay, a real key part of maths is understanding place value. And your children might come home and say, oh, I've been learning all about place value. You think, what is place value? Place value is all about understanding what numbers mean. Understanding that 3, like Mrs. Green just said, is 1, 2, 3. Because that has absolutely no relation to anything to some children. Some children do not understand that that is the same as that. And we've got to teach them that 1, 2, 3 is the same as this. And somebody, somewhere, decided to write the number 3 like that. And children have got to learn that relationship. They've also then got to go on to learn that 4 is more than 3. And 3 is more than 2. And some children, that takes an awful lot to understand that. They really don't understand that. And so we do so much on place value, where numbers come in the number system, which numbers are more, which numbers are less. We go on to look at bigger numbers, and we have to understand when we're looking at 2 and 3 digits, the value of each of those digits. We have to understand that that is not a 1, it's 100. We've got to understand that's not a 5, it's a 50. And that's a 2. So we talk a lot about hundreds, tens and ones or units, and it's understanding that. So we look at that, we know that's a 50, we know that's a 100, and we know that's a 2. It's really important children understand that. It's really important they also understand that what's 10 more? 162. That they understand that the units will stay the same, the hundreds will stay the same if I'm just adding 10 more on then, but tens change and the others stay the same. They've got to understand where numbers come in the number system and have that real understanding. Until they understand place value, until they understand that that is 100 and that's 10 lots of 10, they can't start to do any of these because they can't manipulate number until they understand what a number is and they've got a picture in their head of what a number is. We do lots and lots of work on place value. That's the wrong one. There's my slides. We then do lots and lots of work all about partitioning, and the children love partitioning, and you'll see us doing a lot of partitioning in a little while. And they might come home and say, I've been doing partitioning, and you think, what on earth is partitioning? A lot of the way we teach the 4 operations, we do partitioning, and all partitioning is understanding that 34, we partition it into tens and ones. We've got a 30 and a 4. We've got 3 tens and 4 ones. And it's really important that children have the image in their head of what 3 tens are and 4 ones, so they understand that that altogether is 34, and I can partition it into tens and ones. And also, if I've got hundreds as well and going on to thousands with the year 4s, I can partition it into thousands, hundreds, tens and ones, and really understanding that, because then they can deal with the numbers a lot better. I think it's teens numbers. Just a bit of a warning with teens numbers. Children understand 25, 32, 78 a lot sooner than they do the teens numbers. Teens numbers are horrible because this is 16. If it's 16, why don't I write it like this? 16. Children have real trouble with that. And 11, who ever thought of 11? Why is that 11? How do we know that that's 11? That's just something children have got to learn, so they have real trouble with that. 12, Where's that come from? What does that mean? 12 doesn't mean anything to some children. 25, that's great. 25, I can do that. Teens, they have a real problem with. They've got to understand that a teens number is a 10 and 6 ones, and that is really hard. So a lot of children learn numbers up to 100 from 20 to 100 a lot quicker than their teens numbers. So if they're having real problems with teens, that is usual, and it is difficult for the children to understand that. I'm just going to realign the board, it's gone a bit wonky.
I would say that when this happens during the day, the children now count.
Yeah. 1,
So you get into
5,
fives or threes.
10, 15, and they just do it spontaneously,
Yeah,
do they?
but the parents don't.
Wait till you do it. Right.
Brilliant, thank you. All right, lovely, thank you. Right, once we've started sort of thinking about